Yo, this is Mr. O. Yo, today we're going to learn about proving congruent triangles using side and side angle side. But I'm going to go over also with the other ways like side angle side, and hypotenuse leg. Okay, so let's go ahead now here. So here are the ways to prove triangles are congruent. This is your cheat sheet or reference. Okay, we're gonna do 5 ways. You know, the SSS. SSS means proving that the two triangles are congruent based on its size. If there are 3 pairs of congruent sides, yes, jump into it. You can prove. If you can prove that one, then you can say that two triangles are congruent. Or you can do side angle side. Side angle side means that, so for side is like this side here is congruent to that side, and this two here and this two here. While the side angle side, 2 sides and an included angle. When say included angle, for example, if I say this side is congruent to that side, these 2 sides are congruent, then the included angle will be right here, the one between them, the sandwich in between the 2 sides. Okay, that's how you use side angle side. Okay, and that's what we're gonna focus for today's video. Okay, but let me introduce you also the angle side. 2 angles and an included side are congruent. So if this angle here is congruent to this angle, and this angle here is congruent to this angle, then the side between them, the included side will be right here and there. Okay, that's when you prove that one, that's enough for you to say that the entire triangle are congruent. Or we can have AAS. This angle here is congruent to this angle here is congruent to that angle, and this side here. Okay, 2 angles and a side opposite to them are congruent. That's good. It has to be opposite. So meaning to say, I don't need to have it there. It could be also right here. Okay, that is perfectly fine. Okay, what's the difference? You know, because if you put the congruent side right here and there, that's going to be ASA, angle side angle, because you will see an angle here and a side and angle side and angle. So ASA, not AAS. And another thing is the hypotenuse leg. Hypotenuse legs works mainly for a right triangle. Since they're both right angles, so you know that two will be congruent. So the hypotenuse is the one opposite to the 90-degree angle, which is this side here, the longest side. That's the hypotenuse. And any leg of the right triangle. Let's say we pick this, is congruent to that one, that will work. Okay, that will work to prove that this one here will be a congruent triangles. If you notice, there's no foul word here, or we can say the SSA. There's no foul word here, so it means say that's not a good way to prove the triangles are congruent. Okay, let's move on now. So here are some more tips in proving triangles that are congruent. Reason for congruent side, it's given if it's given, or they mention to you that there's a definition of midpoint, or the reflexive property if a side is congruent to itself. These are the hint that you can use for the reason column on your 2-column proof. Okay. Also, reason for congruent angles. First, if it's given, it's nice to have it given. Vertical angles. Vertical angles, they will not tell that to you. You have to see it on the illustration. Alternate interior angles and corresponding angles, it must be defined that the 2 lines are parallel, or you might be able to prove the vice versa, that they're congruent, and then the parallel lines are going to be and the lines are going to be parallel using the converse. And also definition of angle bisector. This is the creator that creates 2 congruent angles. Is the one that cut it to half. Okay, And also the CPCTC, this is the best friend of mine, is the corresponding pars of congruent triangles are congruent. This case here is that if the two triangles are defined to be congruent already, then then all its pars are going to be congruent. For example, here if triangle ABC is congruent to triangle DF, then I know now that angle A is congruent to angle D, angle B is congruent to angle E, I know that angle C is congruent to angle F, and I know that the side AB is congruent to side DE. I know now that AC is congruent to DF, and what else? BC is congruent to what's that? BC will be EF. And the reason for that one will be CPCTC, corresponding parts of congruent triangles are going to be or are congruent. Okay, let's go ahead now for two column proof here. And again, our focus for today's video is side, 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 and side, angle, side. Okay, so if three sides of one triangle are congruent to three sides of the another triangle, then the two triangles are congruent. So here, just looking at this one here, I know that AB is congruent to where D. I can tell that there are two thick lines here, there are two thick lines there. So side BC is congruent to side EF, and side AC is congruent to DF. Since I have proven that the three pairs of congruent side Since I've proven that the three pairs of sides here of these two triangles are congruent, then I can say that triangle ABC is congruent to triangle DEF. Okay, that's how it works. Okay, so let's jump into this problem now here. So I know I'm given a JL is congruent to NM. Where's JL? JL is right here. So this and that are congruent. Okay. K, so I would say here that this one here is given, right? Next, K is the midpoint of Jn. Okay. K is the midpoint of Jn. If K is the midpoint of Jn, I know that these two here will be congruent, right? So I can say that Jk is congruent to Nk. What's the reason for me to say that one? I said that they're congruent because of definition of midpoint. Okay, and don't forget that K is the midpoint of Jn and Lm. That's based from the given. Okay, next. Since you know that K is the midpoint of Jn, it also said here it's also the midpoint of Lm. So I know that these two here are equal. This orange one, the two thick lines here. So if they're equal, so I can say that Lk is congruent to Mk. That's going to be definition of midpoint. Since I can see that I have three sides already in one triangle here that are congruent to the other three sides, I can jump to a conclusion, and that's enough for me to know that the two triangles JKL is congruent to triangle NKM using side, side, side congruency. And I do not need to check if angle J, or L, or K are congruent to N, M, respectively. Okay, that's enough. Okay, and that's how you prove using side-side-side congruency. Let's go to the next one, side angle side. If two sides and the included angle of one triangle is congruent to the two side and an included angle on the another triangle, then the two triangles are congruent. So in this case here, I see that AB is congruent to DE. The included angle is angle B, congruent to angle E. And side BC is congruent to side EF. And that's enough for me to say that triangle ABC is congruent to triangle DF using side angle side congruency. Included means the angle between the side. There's a sandwich, okay, of the two sides. All right, let's go ahead now. Let's try to prove this problem here. JM and LN are congruent, and that will be given. Angle, so where's that one? JM and LN. It's nice to draw the thick line on our figure to easily see it, okay? That's how I do it. Angle JMN is congruent to LNM. Where's JMN? JMN. So this angle here is congruent to LNM right here. Okay? And that's also given to us. You can see here that MN is congruent to NM. I know that this side here is being shared. Okay, look at this blue triangle and the red triangle here. Are they sharing same side? Yes, they're sharing MN. So MN is congruent to NM. This will be a good reason for reflexive property of equality. Or you can just put reflexive. That's fine with me, you know. Next, try now. We can say that this is equal to itself, right? So I have a side, angle, side. I have a side, angle, and a side here. So I can say the triangle JMN and triangle LNM are congruent using side, angle, side. Okay? Very simple. Let's say this is not the trying to prove. Let's say we're trying to prove JN is congruent to LM. We're not going to change anything from our work here, but I'm just going to add here that number 5, that JN is congruent to LM. Since you have proven in number 4 that the two triangles are congruent using side angle side congruency, since they're congruent, I can say now that the other parts, the corresponding parts, like JN, will be congruent to LM using CPCTC. Again, what CPCTC stands for, corresponding parts of congruent triangles are congruent. If the corresponding parts will be congruent now of that triangles because the triangles are congruent. So that's how you prove it if this was the problem, okay? And that's how you prove using side, side, side and side angle side congruency. And as always, kaboom.